A star is a huge object in space that emits light and infrared radiation due to nuclear fusion in its core. Stars are made mostly of hydrogen and helium. All naturally occurring elements are produced by fusion processes in stars. This means almost every element that makes up your body was once part of a star. All stars begin as a big cloud of dust and gas called a nebula. Gravitational forces pull the particles in the nebula closer together, causing the cloud to get hotter and denser. This results in an increase in pressure that means the particles collide more often. The friction caused when the particles brush past each other increases the thermal energy stored. Light starts to be emitted. This stage is called the protostar. Eventually, hydrogen nuclei gain enough energy that they start to fuse when they collide. This forms heavier, helium nuclei. This process is called nuclear fusion. Since the nucleus of each atom is positively charged, the forces that cause the nuclei to repel each other must be overcome. The extreme temperature and pressure needed for fusion reactions only occurs naturally in a star. The fusion increases the thermal energy stored in the center of the star, which causes it to expand. The expansion is equal to the gravitational pull towards. This part of the life cycle is the most stable. Eventually, the main sequence star will use up all of the hydrogen in its core, and the larger nuclei start to fuse together to make even heavier elements. The fusion of larger nuclei causes an increase in the thermal energy stored at the core of the star, which makes the star rapidly expand. Stars about the same size as the Sun will form a red giant. Stars much bigger than the Sun will form a red supergiant. As the main sequence star expands to red giant, it cools. The cooling is what causes it to appear more red. The red giant is larger than the main sequence star, which makes it brighter. Carbon and oxygen can be made by fusion in the red giant stage. The Sun in our solar system will expand into a red giant in 5 million years. At the end of the red giant stage, fusion stops, and the gravitational forces acting inwards are stronger than the expansive forces acting outwards. This causes the star to collapse inwards. The outer layers of the star are expelled, and the leftover core is known as a white dwarf. White dwarf stars are very bright and very hot because all of their energy is condensed into a small area. Over time, energy is emitted from the white dwarf star to the surroundings. This dimmer and dimmer until it turns into a brown, and then a black dwarf star. Have a look at the journey of stars so far. Main sequence stars, which are much bigger than the Sun, will form a red supergiant when they expand. Elements up to the size of iron can fuse in a red supergiant. The fusion of nuclei as large as iron in the red supergiant causes the core to get denser. When it runs out of fuel, the core is so heavy that its gravitational force pulls the outer layer. The shock waves resulting from this collapse cause the star to explode in a supernova. The size of the supernova will determine the next stage of the life cycle. Most supernovae form neutron stars. The largest supernovae form black holes. At the center of a supernova, the particles form an incredibly dense core. This causes the supernova to collapse into a neutron star. Neutron stars are the smallest and densest known star. Fusion does not occur. The largest supernovae collapse to form black holes. The name might make you think of an empty space, but actually there is a huge amount of matter packed into a tiny area. Gravity in a black hole is so strong that not even light can escape. can escape. Thanks for watching the video. Please like and subscribe for more videos.